Okay, today we're going to be focusing on the plate tectonics theory, and your goals today are going to be I can explain the difference between the three types of plate boundaries. I can explain the theory of plate tectonics. Your homework tonight is going to be reading pages 478 to 485, studying the vocabulary list that you got back on 1114, and also studying your notes from today. So you're also going to be taking a quiz today, so make sure you've labeled your loose leaf as you see up there, crust and convection quiz. Just to let you know which words you're going to be studying for this week, the yellow highlighted words are going to be words that you're studying for tomorrow's vocabulary quiz, and that will be oceanic crust, continental drift, magma, lava, crust, lithosphere, asthenosphere, mantle, core, outer core, inner core, convection, and convection currents. We will also have a vocabulary quiz on Monday, November 26th, and that will be seafloor spreading, mid-ocean ridge, deep sea trench, subduction zone, plate tectonic theory, tectonic plate, divergent boundaries, convergent boundaries, transform boundaries, and rift valley. So, let's talk about some of the notes that we're going to talk about and discuss first, and I'd like you to write these down. Plate tectonics facts number 2 is our mini heading for right now. There are 10 facts here I would like you to copy them into your notebook. Plate tectonics theory: pieces of Earth's lithosphere are in slow, constant motion driven by the convection currents in the mantle. Plate tectonics theory drives the rock cycle. Plate tectonics theory explains the formation, movement, and subduction of Earth's plates. Geologists think that the movement of convection currents in the mantle are the major force that causes plate movement. And remember, that was what Alfred Wegener could not prove, and now geologists know and understand this with today's technology. Number 5. As plates pull apart or grind past each other, they are producing spectacular changes in Earth's surfaces, such as creating and making volcanoes, volcanoes erupting, mountain ranges, deep ocean trenches, and mid-ocean ridges, and earthquakes occurring, and the changing of rocks from igneous to sedimentary to metamorphic. All of those things are happening because our plates are moving. The 3 types of plate boundaries that we need to know about: divergent plate boundary. This is where 2 plates move apart or diverge or divide. Most occur along mid-ocean ridges, and this is where seafloor spreading is occurring, which we will discuss a little bit later today. Convergent plate boundary: a place where 2 plates come together or collide into each other. This results in a collision, causing mountain ranges to form. Number 8, transform plate boundary. This is where 2 plates are going to slip past or grind past each other. They're moving in an opposite direction, and often you'll find that earthquakes are a result where transform boundaries are shifting and moving. Rock cycle. Because of all this movement, the rock cycle occurs. Plate tectonics are the forces deep inside Earth and at the surface that produce a cycle that builds, destroys, and changes rocks in the crust. The rock cycle continuously changes igneous, sedimentary, and metamorphic rock. It is a series of processes in the Earth's surface and in the crust and mantle that slowly change rocks from one kind to another. Okay? So those are the notes you should have in your book, in your notebook now. All right. Do want to talk a bit about seafloor spreading. In your reading tonight, you will be reading about seafloor spreading, and it is discussed on page 478 through 475, or I'm sorry, 479. Basically, seafloor spreading is telling us how or what the ages of ocean crust is and the thickness of the ocean floor, how that increases as the ocean floor spreads apart and moves away from the mid-ocean ridge. So copy these notes into your notebook. I have an illustration here too that I'd like you to draw. Here we have magma, and it's usually stored in what we call a magma chamber. But as seafloor spreads apart, right, there's a divergent boundary here. And as that divergent boundary, it's pushing the seafloor in opposite directions. It's pulling it apart. As it pulls apart, that magma moves upward and seeps out, and it cools and hardens. As the seafloor starts to spread in each direction, so it's moving in this direction, okay, this becomes the older crust as you move further away from the ridge. The younger crust is right here at the ridge. It's the newest, okay? So we're going to add the word newest here. And the oldest crust would be further away. So at the edge of the ocean where it meets the continents, the land, we're talking about the trenches here, okay? At the trench, we have a subduction zone. So that means that part of this, sorry, let me move my red arrow back up here. At the subduction zone, we are seeing this area here. We're seeing that some of this crust is being sunk downward. Okay, so oceanic crust, because it's more dense, is going to sink when it comes in collision with continental crust. So we have our continental crust here, okay, and our oceanic crust down here. And the oceanic crust is going to sink. And as it sinks, it's being pushed to lower layers of the earth, and it's going to hit the mantle and it's going to melt. So we have two facts down here that we need to add to our notes, is that at the mid-ocean ridge, which is right here, okay, mid-ocean ridge is where crust is created. That's where the newest ocean crust is. At the deep sea trench, however, this is where oceanic crust is being changed or destroyed back into magma, okay, and that's called a subduction zone, and that's that area up here, okay. Next, I want to talk to you about just breaking this down into a thinking map, okay. Seafloor spreading. And let me just change this here real quick. I'm going to make this a little easier for us to see all of it in one chunk. Bring this down a little bit. Okay, that works. So seafloor spreading is the name of this tree map. We have two parts. We want to discuss the mid-ocean ridge, and we want to discuss the deep sea trench. Okay, mid-ocean ridge, that's where magma pushes up through the crust, it cools and forms new ocean crust there. Okay, and because it's a divergent boundary, that ocean floor is moving away from the ridge at a very slow pace, but it's happening all the time. And then eventually that crust reaches the deep sea trenches, and that's where an oceanic plate or crust meets up with continental crust. And the ocean crust will always sink because it's more dense, and we call that a subduction zone. So ocean crust is pushed down toward the mantle, melting and destroying the crust, and that's what we call subduction. And it happens at a subduction zone.